The next type of optimization problem we'll look at is something like this. Find two positive numbers whose sum is 110 and whose product is a maximum. So the product of these two numbers, I'll call them x and y, is a maximum. So that's the thing that I want to maximize. So that's our primary equation. Since there are two variables here, two independent variables, I'm going to need a secondary equation also for the constraint. It says the sum of these two numbers is 110. So if I solve my secondary equation for one of the variables, I can substitute it into my primary, so now my primary is all one variable. I can then maximize with the first derivative test. Before I do that, I want to multiply or distribute out the x there so I can get an easier rule for the derivative. So now I'm going to take the derivative. I get 110 minus 2x. To find my critical numbers, I set it equal to 0, my derivative. So x equals 55. If I make my test interval for the product, the maximum product should occur at 55. I just have to confirm. If I plug 0 into my derivative, I get a positive. If I plug 60 in, I get a negative. So that is confirmed that there's a maximum there at 55. So when one of the numbers is 55, that was x that I was solving for, the product will be a maximum. It said find both the numbers. So how do I find the other? I come back up here to my secondary equation. Now you may have been able to arrive at this without calculus, but you still have to kind of show the calculus because this one's a bit of an easy one, but some of them you won't be able to figure out without the calculus. All right, that's another type of optimization problem you'll see.